Alrighty. If you're happen to listen, if you want to give me a thumbs up in the chat to let me know that I do in fact have audio. I'm pretty sure I do, but doesn't hurt to check. Okie dokie. I'll give it a couple more minutes, um, just to let anyone catch on in, and then I'll get started. So give it 2 more minutes. Alrighty, folks. So thanks for coming. Dom can get his beers. In the meantime, so we put this together pretty quickly. I realised there was nothing going on, and figured I could put together a fairly brief talk. This has been something I've been interested in a while, though, so I'm hoping you'll get something out of it. Just a little bit of housekeeping before you get started. Live heckling and questions in Discord or on YouTube. I've put that in the Discord chat as well. If I don't address a question, I'll get to it at the end. And enjoy a bevy if so inclined. I'm sure you can find your own fire exits if in the case of an emergency. Before I get started, I'd like to acknowledge the traditional owners of Lutruwita and pay respects to their elders past, present and emerging, and pay respects and acknowledge their continuing connection to land, waters and culture. Alright, let's get started. So, what we're talking about today is property testing, and I'm not going to be saturating this one in memes, but I couldn't resist this one. So property testing is a fairly intimidating little subject. It's a type of testing that's always been attractive to me, and I find sorry, one moment. Are we not getting any sound through, David? Sound is working. Okay, good. All right, let me start that over. So we are talking about property testing, and property testing is a very daunting little subject. There's a lot of it's a very attractive subject to work with, because the idea is you get a lot more testing done without having to write manual tests all the time. But because of its complexity, because it requires frameworks to do a lot of the heavy lifting for you, it makes it very difficult for you to get started with the whole system. So hopefully what this will be is an introduction into property testing, and hopefully give you the kick you need, or the incentive to spend some time and really invest in it. And it is an investment. It does take time to get into a good testing situation with property testing. So to start off with, let's talk about what testing is, and these code examples will be in Elixir. It looks a bit like Ruby in a lot of ways, and it will hopefully not be too daunting to just read along with this code. So traditional test writing is more like example testing, and what that means is you write your tests, but the way you test your code is often you say, all right, well, if I give it these two arguments or these particular arguments, and then I'll result in some sort of output. And a lot of the time, you're just throwing things at the machine. You're coming up with cases that might trip up your machine, and you're trying to think of all of the problems that might arise, and you write your tests to match those. And while that may seem simple, it's simple to get up and running. You can run a very quick test and say, all right, is this adding machine, does it have this adding machine which literally just adds the two numbers together? Does it take those? And we know what the result is, because we can do that math in our head and test it. Obviously, as you get to bigger and bigger scenarios, you start to find bigger and bigger problems, and you need to eventually try and think well beyond the box to find all the possible ways that you can break your machine or break your program. And the big problem with that is it's time consuming, and it puts you in a situation where there's only so much time you can put towards testing, and you never feel like you've tested enough. So example testing, an example for me is, example testing is where you have a train line and you've put one train down that line. Well, maybe you've put a couple more, but you don't really know if it's going to actually support what you're actually going to put on that train line, which is eventually thousands of different combinations of input. And that's what you want to actually be doing. So your deserted testing of a train line is on the example testing side, and then your much more complicated, multifaceted, lots of different types of input. That's what property testing aims to do. That's the benefit there. I'm going to kill off my webcam so that I can see all the code. You can see all the code examples and whatnot, and then we're going to talk about properties. And to start off with, so I know you probably, if for those uninitiated to properties, it'll start to become clearer over time. And the two key sort of bits of terminology here are properties themselves, which are a test of a relationship between input and output data, and generators, which are functions that generate randomized input data for property tests. So the randomized is the big part here. So property tests, you don't set the input data, but rather you create generators that make that input data for you. And the idea behind that is that you can get a much bigger testing space from them. So a potential property could look like this. So here we've got, on the first line, we've got a property that is essentially checking if the adding machine correctly adds things. And yes, we've pretty much just re-implemented the adding machine here, but we'll talk more about that in a moment. So if you read the top line, you've got just defining the property. And then after that, you've got this for all statement. And the idea here is you feed it a couple of generators. In this case, we've got 2 integers. And then we run some sort of test on them, and that's got to return something like either true or false. And here, we're just simply testing that the adding machine, when it's given an X or a Y, that the result of it equals X plus Y. So that's a property. We're testing for a wide range of randomized input, whether this thing that we've got is going to do the right thing. And you can see the same thing at the bottom here, where instead of testing a whole implementation, what we're testing is for a function that reverses a list, is the list length remaining the same? That's sort of one property of our code that we'd expect to be true, right? So here we're testing, okay, is the length of L and is the length of something that's been reversed, is that going to be the same thing? So this list call with an integer inside of it, that's another generator that generates a list of integers. So here we've got a couple of properties that can form part of our testing regime. So the generators that you come with, pretty much every property testing library will come with a large array of primitive generators, which generate all your primitive level data types. And so part of the reason I'm not going to focus much on a particular language here is while all my examples are in Elixir, there are property testing libraries for all sorts of languages, all of varying qualities, and we'll talk about them at the very end. But other than that, we really want to focus on the idea of property testing. And here we've got primitive generators. So you've got your integer, or you've got a negative integer, or a positive integer, or you've got a list of integers, or you've got a way to force say you want to very specifically only test non-empty lists, you've got some modifier sort of generators as well. So all these property testing kits are usually going to come with a range of sort of base level generators that can work quite well for you. But that won't be enough, and you'll often end up with custom generators as well. And the idea there is you'll get a couple of generators. So this is a bit different than the for all statement before. This is a let statement where you take a range of generators. In this case, we've got UTF-8, a pos integer, and a one of red and blue. So we're taking those and then we're putting them into what is essentially a map in Elixir, okay? We're creating a person with a name, age, and a favorite color. And the idea behind this is this allows us to generate more complex data structures. And what you'll find when you're testing code with property-based tests is, again, coming back to that whole investment thing, it takes time to build up your huge array of generators, but then once you've got those generators, you can generate tests that fully exercise your system in a way that you would never really want to write by hand if you could avoid it. So now those properties, let's go back to these particular properties here, okay? So it's all very well and good saying, all right, it's a test where it returns true or false, and you can use that test to determine whether your code is working. But when we talk about properties, there's a couple of names, and these are one of the big things that, like, when I was reading some recent books about it, these are the sort of the things that really blew open the concept of property testing for me. So in terms of properties, there's three big types, okay? So the first one, modeling, is an obviously correct partial or complete implementation that you can test against your system. So the idea being that you have something that sort of largely works the way you want it to, or maybe it's less efficient, or maybe it's obviously correct. Some way that you can sort of test and then if you get the same result at the end, the model gets the same result as your actual running code, then you're all in a good situation. Obviously, you don't want to be writing your code twice if you can avoid it. You're not actually testing anything if you write the same program twice. But modeling, if it's done right, can work really well for you. Invariance, and this is the one that you'll be leaning on a lot more often when you're doing property testing, is an isolated rule about your system that should always be true. So an example of that would be the bottom property here, where you're checking if the list length remains the same. You can't check the whole functionality of enum reverse, which is just something that flips a list. You can't check the whole functionality with that, but you can check a part of it. And then ideally with a number of other invariants, you can end up with a robust system. And then one last property is a symmetrical property, which is something which tests a symmetrical part of your system, such as an encode-decode relationship. Or for instance, for the reverse function, if you ran that function twice, you would expect to get the same thing as what you put into it. So anytime where there's a bit of symmetry, that lends room for another type of property. So we're going to jump into some code now, that old live demo chestnut. So to start off with, I'm just going to run these tests and see if they work. I certainly hope so. Okay, so those tests ran. I'm now going to chuck open trace, which will give us a bit more information about whether those tests run or not. Very good. Okay, you can see all them ran fairly quickly. So when property tests run, they do a bit more than just run the code once. In fact, here I've set the number of tests to be 1,000. And what I'm going to do is I'm going to change to a verbose test mode, which means all these tests are going to roll out, and each of these individual dots here represents one test. Okay? And that might feel a little bit opaque, it can be, but the idea here is, this is probably the hardest part of property testing, is you've got to know what it's testing with. And there are some tools that you can use to do that. So for this particular library, it has these tools for aggregating content, or aggregating your results and then things about those results. So here what I'm going to do is I'm going to really quickly put together a to range. I've already done this before, so it should hopefully be fairly quick. But what I'm doing is I'm going to take the length of these lists and use that information. Hopefully not mess that up. Yep, there we go. So if I make my way up to this little section here, this is giving me some statistics about this test. It didn't just run the test, so this was the quicksort naive against standard library. It didn't just run that test, but it also collected these statistics. So what this means is essentially 33% of the tests were with lists of 0 to 5 elements, 21% of the tests were with lists of 5 to 10 elements, and 14%, and so on and so forth. So that's a way that you can sort of peer into the system a bit. That said though, let's break some of these tests and then see how it holds up. So I'm just going to turn off the verbose aspect of this, just so we can get a little quieter output. And I'm going to break my quicksort. So this quicksort here, I've implemented it down here. Okay, like all functional languages, it's sort of a weird flex to always do a quicksort. So that's your quicksort here. I'm going to swap the greater than and the less than, and I'm going to run this test again. And this time it should fail. So here you can see that we've got ourselves a failure. And what it's essentially telling us is that some aspect of that particular property, so this one here, the quicksort naive, so that's this particular property here, it had itself a problem. Okay, so it didn't sort correctly when it had a case of 2 items long. And this is a big aspect of property testing, is while it is randomly testing all sorts of different sizes, what it does after it hits that point is it then aggressively shrinks down to the smallest possible failing case. And what that means is generally you have something that is genuinely debuggable. You won't have a list that's 200 entries long or whatever, and it would be really hard to sort of keep up with what's going on. So here we've got a fairly simple case where you've got you give it this and it doesn't end up sorted. Unfortunately, there's sometimes not the greatest of output here, but generally you want to sort of play with these tools. Sometimes you can just throw in a print statement or an IO inspect, or you can collect if you're not sure of the reasons why this stuff has happened, okay? But in this case, we know what we did. We broke our quicksort. So let's fix up our quicksort and we'll be back in business. Okay, so now let's talk just a little bit more about what it means to have these different properties, right? So here we've got modeling at play. Okay, so here we've got a adding machine, and then we've got another function called model adding machine. And the idea is this is hopefully a simpler implementation or another way to implement it that checks this particular output. In this case, I've thrown enum sum at it, which is a way of adding up the contents of a list, which, I mean, obviously it's a trivial example, but it's an idea of an alternate means with which we can calculate the same answer as the actual adding machine, which is this guy down here. Very complicated piece of programming, definitely my best work. Anyway, so that is an alternate way to do something, right? Now, another way of modeling is to use, this is like referred to in the book I mentioned before, and I'll throw a link to it at the very end. They refer to it as an oracle, which is simply put, it's a definitely correct sort of alternative either library function or something like that can be used to verify the effectiveness of your sort. You can imagine for things that you are testing for performance, you might have an old implementation, and that is actually a potential oracle for your new implementation that you could run a property test against. And that way you're checking, making sure that you don't have any regressions. Obviously, this implies that you're writing code that can be tested in this manner, but if you can, then it's a great way to set yourself up for success, because you've got something that you can test against. Another, a slightly more complicated case that I've used in the past is where I've actually ran my tests against an Excel spreadsheet. I use programmatic access to put values in and then suck the values out. And the thing is the Excel spreadsheet was the thing you gave to the subject matter experts who could actually they were the subject matter experts who could investigate the Excel spreadsheet, make sure that that was correct, and then I'd write my code to do the complex calculations against it. So oracles, if you can find them, are extremely useful aspects of modeling. Now, if we scroll down a bit here we've got some examples of invariants. So the idea of an invariant is you're expecting these to remain true, and each of them on their own is not enough. But as you grow them into, like, as you build up the case, as you're starting to check more and more things, you start to create a more airtight net of tests. For example, here we're checking, first of all, does the list size stay the same? Yes, it does. Very good. All right. Does the first item become the last item when you reverse it? Yes or no? Does the last item become the first item? And while these are all very small tests, the idea is we're building up these cases bit by bit. And if any of these fail, it should stand to reason that it should be fairly easy to see where the problem lies. Depends on the size of the failing case, but that's what we're aiming for, right? Finally, if we go down the bottom, we've got our idea of a symmetrical case. So here, we're still testing the reverse function, and we're simply comparing whether the original list is exactly the same as a list if we reverse it twice. So there we're checking symmetry. And as said before, symmetry could also be an encode-decode function for, say, JSON or something like that. It's still the same sort of idea. Okay? So this is what property testing is for in like the small cases. Like these are the ways to think of how you're putting bits together. However, it can be hard to get a feel for how you're going to use this as a web dev if you're not making use of sort of larger, what's the word I'm looking for? It's hard to sort of find its direct application when it feels like you're making just a create, read, and update and destroy application. You wonder, okay, how useful will this be? Well, so I'll bring this up real quickly. So in the comments, there's a reverse only needs two properties to specify complete correctness. The symmetry one here, and also that reverse of one case equals the other. And this is the good thing about it, right? If you know enough about your code, and this is what properties are really good at, they allow you to really explore what are the things that need to hold true for your code. So it's a very useful way of thinking about things because it allows you to think really more precisely about your code and then end up building a much more airtight testing system for them. Anyway, I'm going to carry on, and next up we're going to talk about properties in a more web dev sort of scenario. So what I'm going to do is I'm going to jump into some code that I'm actually building out. And here, there is going to be a lot of stuff, right? So there's a larger system at play here that accesses a database and makes changes. And what we're testing here is just a small sliver of that. The idea is that when we run certain actions, certain changes take place based on the parameters. And what we're testing is certain aspects of that. Like here, we've got this thing that creates a facility. This is for an application that I'm working on called Spanner. And if you didn't already catch it, didn't glean that from the names there. But anyway, when you create a facility, certain things happen. First of all, you're expecting that the name will equal the same one as you gave it, right? So here we've got an we've got a generator of a facility, a generator of account, and a generator of a user, and those things get fed into this sort of system. We create the facility, create the account, and then off we run this action, and we're expecting certain things to happen at the end of that, namely that the name is correct and that the account ID is correct. But then there's also some side effects that happen because of it, and we also test for them too. So we check that a log entry is generated inside this little action, so it checks that there's exactly one, and we also check that we get an accurate log entry that in fact does represent all of those bits and pieces here. And the good thing about this is it's going to exercise our code in a it's going to at the very least run our code and give us a sanity check on the things that we expect. And as we go into more complex cases, which I haven't quite got there with this particular app, as we go into more complex cases, it'll be more clear for myself at which points I'm sort of able to, I'll already have that testing framework in place to handle those more complex cases. So we're going to run these tests, and hopefully it should all blast through pretty quickly. So there we've got a range of tests that have run, like they're creating facilities, creating roles, deleting roles, all these sorts of bits and pieces. And a lot of them are simply matches supplied params, because it's just the user enters some data and we have to make sure that that data ends up on the other end. But as this gets more and more complicated, there's going to be more things interacting with one another. So it's important for us to be able to deal with that. And here's a point where I would, oopsie daisy, I logged on out. Here's a point where I would say that it's important to understand that just because you have property testing doesn't mean example testing doesn't have its place, right? So if I look at facilities, if I look at my tests here, I have a lot of test cases where I still use the generators to pick out some data, just because I don't want to have to hand write cases all the time. But I do make use of these and just do simple assertions, because I just want to essentially do an end-for-end check. So tests still have their place, or like simple example tests still have their place for just checking that everything's all good, because I can also go to the API level and test that when you do certain things, like for instance, here, this one here, doing a post request to a particular point will actually respond correctly with the name and the account ID and all that good stuff. So we're setting ourselves in a good place. We've got the property tests for when we really need to exercise a bit of code, and we've also got simple example tests when we just want to make sure that we wrote the code correctly and we don't want to have to run up the server every time just to check those sorts of aspects of it. And you know what? Property testing would be pretty dope if it was just that. Like, if it was just that, you could still get a lot of mileage out of property testing. But the problem with systems is they get complicated. I might just take one quick moment to show you some of the generators I've got here. So for a facility generator, we've got this idea of, we've got a name, an account ID, and for roles, we get a name, an abbreviation. And those, because I wanted to make just some nice names rather than just throw UTF-8 at it, I essentially made a bunch of word lists that often will do all sorts of different things, bringing together different names, different operations, different suffixes. There's all sorts of things that you can throw at your generators. And the idea is if you build up a large enough set of generators, you can really exercise your code. But also this could potentially just form a really good basis for your example tests too, because you can just throw the generators in the same case. Again, it's an investment, it takes time, but once you have it, it's extremely useful. And that's where we get into sort of the point where property testing goes from something that's nice to something that really exercises your code in a way that you probably wouldn't get around to if you were doing pure example testing. So let's talk about that. So stateful property testing is where property testing goes nuts. So unlike the simple properties that we were doing before, what we have is we have a small bit of code, we run it, and it's got to run as quickly as possible. And the idea is that running test will not really change much. They'll all be they're good unit tests, I guess, where I'm getting at. Stateful property testing is different. Stateful property testing is where you have a system that you're testing and you want to throw random commands at it. And you want to generate those commands, and then you want to make sure that it's always doing what it's supposed to be doing at all of these random commands. And these command sequences could be 40 elements long, 50 elements long. And you would never write that test case on your own, but you could potentially create test cases that you would never run into through this through putting the time into this random generation. So when you do stateful property testing, you need 4 things. You need a system. This is the actual system that you're testing. You need a model, which is a high-level representation of the system, which aims to be simple and predictable. So this is the same as a model property in that you want things to happen in this model that are obviously correct. Instead of using a database, you could just use an object or a map or something. There's all these simple shortcuts that you can take with your stateful property testing, which sort of ignore all the larger details or larger details in favor of just an obviously correct model that you can test your system against. It also has a command generator, which is a function that generates a sequence of commands to execute against the system. And it has post conditions. So the idea is these conditions will run after your commands and verify that your system actually did what it was supposed to do. So this will all sound a bit scary, and maybe I'm hoping it will become clearer as we keep on going forward, right? So the system. Generally, we don't call the system directly. This is another really great idea that I've only recently come across. Instead, we create a shim which represents all the different types of actions and what kind of arguments would go towards it. So here, instead of directly calling the database function that creates a facility or the route that creates a facility, we create some looking repetitive, but they are useful in that each of these sort of cases will have a slightly different result. So if we call the API and create a facility successfully, that's one result. If we call the API and create a facility, but we don't have access, it should be a failure. That's another result. All of these sorts of things mean that we can exercise all these different cases. And the idea of having a shim in place is you can change the underlying representation and not have to adjust your tests too much. But that's the system. We're testing the system. These are the things that actually get called that we're actually verifying. We also have a model, and we don't represent the whole system. We just something simple to understand. So as I was saying before, it could be a simple map that just has a list of all the things that should exist at a given point in time. And ideally, you should be able to see, well, when a create facility takes place, and I know that there's one more facility on the list, I can keep track of its ID, and that's enough for me to keep track of its existence. I don't need to keep track of all the other aspects of the system while that's happening. We have command generation. So we create a generator that uses generators as well to create those random commands. So often with these generators, you want to have a little bit of logic in it. Like you only start creating facilities once you know that accounts exist. You only start creating accounts once users exist. Here we've got a test where it's going, okay, if there's accounts, then I will make a call. Now, a lot of this will seem like seem a bit overbearing, but if we talk it through this first line where it has API create facility. So first of all, we've got a number 1, and we're using that as a weighting. So we can put a 10 there, and it'll be 10 times more likely than anything with a 1, and that gives us a bit of a probability weighting for the system. The call is always like that because it's a function call. The module just means calling this particular module, and then we've got the name of the function, which is API create facility, and then under that we have got the arguments that will be called, that function will be called with. So in this case, we've got one of user IDs, and we've got a generator for a facility. So the idea is this is what's going to be generated when we call the system. And then it keeps on going, and we can see here that once we have facilities, we can also rename facilities or fail to rename a facility, and also create roles for that facility. So here we've got some additional commands that only can possibly exist once facilities are in existence. And we've got some different weighting for them as well. You can see the 2, the 1, the 4 over here. These are different weightings that can take place. So in addition to that, we get better command generation with preconditions. So we have pure randomness, but sometimes what we need to exist is we need to have just some existing and extra checks. And one of the big ones that comes into play for a web application like this is access checks. Okay, you need to make sure that when you've got a condition, for example, rename facility here, you need to make sure that this person's going to be permitted to act against the facility. For example, for this one here, API rename facility. But then the flip of that has got to be true. If you want a failure to take place, you need to make sure that they don't have permission, which is what this second precondition is here. So the idea here is to, if you just threw pure random at your system, you wouldn't actually be testing it the way you want to. So the preconditions help you filter that out a bit. And then you've got some aspect that changes the model. This again is stuff that I've built up over time, but the idea is you only need to update the model when you have something take place that should result in a change. So when things are created, when things are maybe modified depending on what you're keeping track of, but other than that you can just return the state. So the idea is for API create facility, we're going to push that, we're going to keep track of that facility ID, that's what the result is. And then for creating a role, we're going to keep track of that role ID. But other than that, we don't have to do anything. So your state is, again, that most simple possible implementation. For a complex system, even that simple implementation can be difficult. But as long as it's obviously correct, that's the main thing that you want to get out of this. So when command generation takes place, it'll have that initial state, which is this guy right here, and then it will generate a random command, test the precondition, update the model, and then keep on going around to generate commands. So essentially it generates a list of commands. It could be 10, 20 long. It'll start off small and go bigger as time goes on. But the idea is it's testing and seeing all of the different things that it should ideally be able to throw at the system. That's all up to your generator. It's not actually testing your system at this point. Once it's generated that list of commands, then it enters into test execution. It starts off the same way. It runs the initial state, it gets the next command, tests the precondition against that command, but that's against the model, and then it runs the command, and this time it's against the actual system. It updates the model using actual system results. So if you have something that's not deterministic, like say UUIDs, which are like purely going to be random coming out of the system, even though they are because they're coming in, they'll update into the model and you'll be able to be sure that you're actually able to keep on running the system with genuine IDs. So that's why you use actual system results. After that, you test the post condition, which is just, did this command do what I expected it to do? And then you go get the next command and keep on going and going and going until you either hit a failure or finish successfully. All right, that's a lot. But let's not panic and let's just try and run some tests. And again, this is about maybe making the case for investment, not necessarily getting you at the point where you could actually do this straight off the bat. So what we're going to do is where shall I grab them from? I'll go grab them from planning. So inside the planning API, I have this property here. And it has this concept of, all of these things sort of need to wire together. So we have an initial state that comes out. Again, I've created a helper for all of this stuff. And then I have a range of commands that I'll give it from accounts, from facilities, and from planning. And all of these tests come together to make our stateful testing. So I'm just going to run this rather than waffle on too much. And we're going to talk about what actually came out of it. Where am I going? I believe I'm going spanner web, API, planning, test.exs. There we go. All right. So when I run this test, I've got it set to run 100 of these things. And these take a little bit longer because they're actually exercising the database. So every one of these single dots involves a complete teardown of the database. Yeah, it's starting from scratch again. Okay, so here we go. So in this test generation, what we had, and so these statistics, just to show where they're coming from, they come from a collection of the length of the command strings and also this aggregation thing that keeps track of how much each command got exercised. So if I scroll up a bit here, hopefully I can get all the data. Yes, I did. Okay, so these 100 tests. In these 100 tests, these are the commands that ran. These top set here, and what percentage of them ran. And here is the length of those command chains as well. So 1% of them were of 40 to 45 commands long, 2% 30 to 35 commands long, and you can see it's going from there. And then here you've got various lengths. So 12% of our calls were inviting new users, 12% were renaming priorities, 11% creating priorities. So there's a few things going on, and it's exercising various parts of the code. There is a few issues with the generators as I've written them because it really needs to generate the exact right invited users in order to do some of these things. So that's why these are a little low on. If I wanted to make this a bit better, I'd have to play a bit with the generators. But the idea here is our code is getting exercised in a range of different ways. Now, if I jump into so each of these is facilitated by a shim, right? So our facilities shim has a range of calls. It also does command generation, and it also has sort of the post conditions in place. So if we look at, say, just one of these commands here, you can see this is the command generator here, and here, this API create facility, that's the generator that actually creates the facility for us. And here it's got the generator. So one of user IDs, it generates a facility using one of the existing account IDs, right? Now, in addition to that, let me go down a bit further. So here's the actual call. So here we're creating a facility, and this is what actually does the work. And here we return the ID, because that's what the model is going to use to make everything work. The ID, like the model to keep track of, okay, how many facility IDs have I got and what are they? So for future calls I can use them. Now, if we go further down, what we've got is, actually I'm still in the API stuff. Here we've got the precondition checks. So again, this is really repetitive code, but in tests, it isn't actually the worst thing in the world to have repetitive tests if it makes them understandable, right? And here we've essentially got a range of checks, like when we create a facility, we have to make sure that that account exists and that our user that we've been given has account access and it is allowed to do the things that they're meant to be able to do. And that's, again, I've made helpers for all these bits and pieces. Here we've got preconditions for facility management, and all of this comes together to make sure that the right commands come out. Now, if we go further down, we've got the point where the state changes. So here, when a facility is created, we store that facility. When a role is created, we create that role. And when a role is deleted, we also delete that role. We haven't implemented deleting a facility yet, so it's not here yet. And then finally, we have our post conditions. And here's where it can get interesting, right? Because we've got these situations where, see, in the case of creating a facility, we want to check that that facility actually exists. If we're supposed to have a failure, we should check that we get a 403 response, for example, and ensure that we are actually getting told that we've got insufficient access available. And all of this carries on to essentially create all these little tests of all these different routes, which by themselves seem trivial, right? But once you start to put them together, they start to become really powerful. For example, let's break our system here and make it so that you can, let's see, one of the ones that gets checked here. Let's put a case where, let's break our security checks for updating the facility and see whether the system catches it. I mean, obviously I'm framing this as if I know that it will catch it, but let's go there. So we're going to go to API facilities. Again, you don't need to really know how Elixir code works. I'm just going to break this and then we'll go from there. So here, this line here is what I use for my security check. It checks if someone's allowed to do the thing that they've come to that route for. So I'm going to remove that security check. I'll comment it out instead. And we're going to run this test and see if the system finds it. Aha! All right, so it's now shrinking down and now it's got ourselves its minimal case. Shrinking is pretty cool when it comes to these kind of system. What it does is it takes all the commands and it just starts taking out elements of the commands that it used to get there until it gets to the minimum number. So it'll just take commands out at random and see if that actually had an effect on whether the thing worked or not, and eventually get to the minimum case that can result in the problem. So in this case, I removed a security check, and what that meant is you could invite a new user who shouldn't have access to do the thing that they were meant to do, and then they try to do it and they succeed, which shouldn't happen, right? And there's not enough in this counterexample, but with the, let me just bring up the test file again. Whenever a fail happens, I throw out an awful lot of state here, which will hopefully let me debug this situation. So here, at the first part here, we've got an exception. That's something else entirely, something broke entirely. So not sure what happened there. It's a good thing regardless. Actually, I might run that again, see if I can get the break that I actually want. This is one aspect of random testing that can run yourself into some problems, because it doesn't actually, because it's not deterministic, you sometimes end up with cases where you don't quite get the results that you want. So let me just, I'm just going to scrub that example out and see if I can get something more what I was expecting to happen. And yes, this is the demo gods. It's all pretty standard stuff, as you're all can attest to. Anyway, you can run it with a specific seed, but I didn't do that. I'm not going to worry about it too much at this point. This is what I actually wanted to happen, so that's all good. Right, so you can see here, we've got this post condition, which expected a response with a status of 403, but got 200. So that was that little test that I put in place, where if we look in planning.test, hang on, which is shim facilities. So it's this post condition here, where it's expecting a 403, but it got a 200, okay? So something failed in the post condition, and that's what we wanted, right? We wanted it to catch that error. And like, this would all be pretty intimidating if it was here on its own, but you do get a lot more than this if you output the put the error data like I did for this one here. So hang on, let me just bring it up again. So this part where I'm seeing the result, but what I can also see is exactly what the state was at that time. So here I've got a range of accounts, or I've got an account with one facility, one ID, one user. And I've got a facility with some priority levels and roles, and I've got some users, and they've got particular things that they should have. And this is the user in question here, right here. He's got access to assets, to working, to planning, but not to management, which is what that user needed to have in order to do the work that they needed to do. And what you can also see is, now we'll see this result here, which isn't what we wanted, but then you'll also see a full history. So you'll see each state change that happened over time. So you can see this original creation, and then after that, the user that came from that, and then after that, the account that came from that. So you got a step-by-step look into the state that led up to this bug. I mean, this one's a pretty simple one because we deliberately introduced it, but with all of this available, it should be possible for you to bug some fairly nasty state conditions that you probably wouldn't find if you were just example testing, because the big problem with example testing is you're just testing your assumptions. You're not actually you're testing the things you know about the system, but you can't necessarily find the things that you don't know about the system. So I'm just going to where was I going? So I'm going to fix that particular security checkup, and we'll go to facilities.ex. Right. So what we're going to do is introduce something that might be a little bit nastier. For instance, what if when we did reordering of certain things, see, we don't actually delete things in parts of this system. We just flag them as deleted so we can keep the history for them. Different story for users, but for this working data, because there's a need for logging, we want to keep it around and make sure that it's still in place. So, for instance, if we were to, let me just jump in here into the actions. Let me just run a test here where I check, or rather I remove the bit that checks whether all the bits are deleted or not. So here, this makes sure that when it moves things around, it's only going to work on the things that are deleted, not on the things that aren't deleted. Now, if we take that little bit out, is this system going to find this particular problem? Possibly not. Oh no, here we go, we found it. So this particular time, it found a problem in the fact that if there was, and where are we going to find it? Yep, so we found a reorder that takes place down here, and it will probably find that there's another deletion of a role somewhere in here as well, but maybe not. Oh no, this is something else entirely. It was a client error problem. But either way, this would be the start of an investigation. And as I said, this randomized testing doesn't always result in exactly what you expect. And honestly, my code's probably not nearly as sound as I think it is. But either way, you've got a way to really hit your code with all sorts of different permutations and from there you can take that as an investigation to find out what exactly was causing that issue. I'm not going to do that particular aspect of things live because that can be a bit frustrating to watch, but that pretty much brings us to the tail end of all I've been talking about, okay? So this is a massive investment. I'm not going to act like you can't look at this massive system and think it's not maybe a bit daunting. But if it's put together well, you'll end up in a situation where you can really rigorously test your system in a lot of different ways. And certainly I'll come back to that issue and I'll be able to sort of track it down, work with it, find it, and find out what exactly is causing it. But either way, what you end up with is a fairly rigorous system that can test all bits of aspects of your system. And you can have a lot more confidence that you'll be finding bugs before your users do. Because you'll be able to test your assumptions pretty easily with a test case. Like, example tests are a great way to test that you wrote the program that you think you are writing. And then what ends up happening is you end up in operating with like users actually using your code, and then you end up with a whole lot of other things going on in all sorts of different orders that you couldn't think of, and that's when more defects in your programming come up. And we could all try and be perfect programmers, but the idea is that does not scale as a concept. You always end up with little issues that are coming up, and you want to be able to make changes with surety, with certainty. And a system like this is a way that you can gradually build up your system to make it work the way it does. So with those state tests, I will just add a couple more things in here. Things to be aware of if you're going to do state tests on a web development system. You have to figure out ways to make it go fast. The testing system that I've got for Elixir here is really nice in that it does the bare minimum it needs to like sort of bring up the test databases and bring them down, which is great. It hasn't got too much overhead. The other one to watch if you've got user creation is password hashing. Password hashing can make these tests extremely expensive. So the way that gets handled in this system is we change the amount of rounds that bcrypt will do. In this case, I'm using bcrypt, but I mean, whatever your password hashing system is, obviously for test cases only, you bring that work factor right down so that way you don't end up with each test taking about a second or longer because of whatever work factor you've chosen. Right, so if you want to learn more, the book that really blew this subject open for me was the one that was luckily for Elixir because I like writing in Elixir, but it's the property-based testing with Proper, Erlang, and Elixir. And a lot of the concepts, like in terms of explaining how properties work, in terms of explaining how stateful testing works, he's done a great job in pulling it all together. It's a really good buy if you're really interested in this sort of testing. It really does a good job of explaining things. There are potential libraries for all sorts of languages. I've thrown a bunch in there, and I can't necessarily say I've used them all in Angular. I've used Hypothesis for Python, and that's the main one. There weren't really, the last time I investigated property testing for JavaScript, these two weren't around, so I can't necessarily speak for them, but if they're taking this sort of thing seriously, they're really useful, even if they're smaller bits and pieces that will help you. Yeah, like they're all smaller pieces of puzzle, which if you can start to make your investment into property testing, you can get some really good yields out of them. As I said, it's a long journey and it takes time to get to the point where you really want to be, right? That's pretty much it. So if you've got any questions, answers, or anything like that, questions or comments or anything like that, throw them at me. I can either answer them on the stream or we can retreat to the Discord voice channels and have ourselves a good time there. Yeah, that's pretty much it. I'll give a quick moment for questions if there is any, and then I'll carry on. Yeah, so the question is one problem I see often is people writing tautological tests. Do you have tips on preventing that? Let's add 1, 2 equals 1 plus 2. And I think that's just always going to be a problem when you're getting started to it, because it's hard to think about what properties are ideal. This is why I think it's important to think about properties in terms of, okay, what are the things that you actually need to prove your system? And what are like modeling, invariance, and symmetry. It's like modeling is tricky, right? Because you don't want to just write the same code again, but at the same token, you've got to write a test somehow. And like a lot of like testing in general, I think it requires a lot of discipline, someone to really champion it and work through it in the system. And like the argument for the book that Fred Herbert wrote is, if I want to be able to work with my coworkers with property-based testing, I sort of need to be able to explain it properly to them. And I think no matter what, you're always going to have to be, like if you want to champion property-based testing, you've sort of got to make the point that you're going to lead people through it. Because yeah, I don't think it's easy to write properties. It's never been particularly easy for me. I've had some really good wins, as I said, like using the Oracle model and using like an Excel spreadsheet or something like that, so I could get that checked by subject matter experts. But there's not one size fits all. But again, I think it forces us to really think about our code and really explore what it means to write that kind of code. And as you said before, like reverse only needs 2 properties to specify complete correctness. That's an exploration that's really really interesting to work with, and I think it forces you to really work with your understanding of what your program is actually doing. So I think properties can be really instructional as well as a useful way of obviously creating some bulletproofness in your system. Right. Well, I think that'll probably do. So thank you for watching. Thank you for showing up, seeing what's going on. I don't know what we'll do next month, but I think if we're all still stuck in our little luxury bunkers, then I think it'll make sense for us to try and do something next month. So if you have a talk in mind, like to get set up for streaming and whatnot, let us know, and we'll go from there. But other than that, if you want to carry on the chats, I'll see you in Discord.